All right, so I wanted to tell you a little bit about systems in three variables. So when we had two variables, we had the situation where the lines either cross in one spot, so you had one solution xy, infinitely many solution in here, which was the equation of one line, and then no solution. So similarly, how can you tell if a system with three or more variables has no solution, one solution, or infinitely many solution? So the key in here is that, well, in this case, they're not lines anymore, they're planes. So you can have, you'll see in Calc 3 equations of planes and how planes can intersect, but you can have planes that are parallel. So think about like floors in a building, they're parallel to each other, so they don't have any points in common. So then if the equations represent point in a story 1, story 2, story 3, then we'll have no solution. So if you are given a system and you find the reduced echelon form, right? This is reduced echelon form, and you get to a row that has something like this. So the last equation, this is for x, this is for y, this is for z. You basically get 0x plus 0y plus 0z equals 1. So you get 0 equals 1. So if you get that, then we say that there's no solution because this is false. This is a false statement. Then if we saw that there is one solution when you get something like this and you use back substitution to solve it. So if it's normal looking like that, we say that each variable is a leading variable. So you'll get a x, y, and z. So the planes intersect in one point. Or if you do the row echelon form and you get a row of zeros in the end, we have infinitely many solutions. Okay, so this is, we'll do an example like this. So I'm going to skip this one for now, and we're going to do the second example. So determine whether the system is inconsistent or dependent. If it's dependent, find the complete solution and express your answer in the forms of t, where x is that. We will see in a second what that means. Okay, so my first step is find the augmented matrix. So the augmented matrix is going to be the coefficients. So it's going to be 2, -3, and -9, and then the free term is -5. And then 1 for x, there's no y, so 0 for y, 3 for z, and 2. And then -3, 1, -4, and then -3. So let's find the row echelon form. Okay, my pen is leaving me. So to find the row echelon form, let me see if this is too much. The first step will be to make this a 1, but notice that this is already a 1, so nothing stops me from interchanging two rows, right? Just like rewriting the system with the second equation first, it's not changing the system. So this is our first step. Interchange row 1 with row 2. So I'm going to have row 2 is row 1, so 1, 0, 3, 2. And then row 1 is row 2, 2, -3, -9, -5. And then row 3 stays the same, -3, 1, -4, -3. Okay, so that gave me the leading entry to be a 1 already, so I didn't have to do much work for that one. The next step is to make zeros below the leading entry, right? So I need to make this a 0, and then we'll make this a 0. But we're going to do one thing at a time. So I'm going to leave row 1 unchanged and row 3 unchanged. So I'm going to write that. So 1, 0, 3, 2, -3, 1, -4. 1 should be here. And then -3. Oops. And then in the middle, row 2. So how can I make row 2 a 0? I need to take a multiple of row 1 and then add it to row 2. So the right multiple is -2 because -2 times 1 plus 2 is 0. So negative 2 times row 1 plus row 2, that's going to be my new row 2. So negative 2 times 1 is negative 2, plus 2, that's a 0. Negative 2 times 0 is 0, plus negative 3, that's a negative 3. Negative 2 times 3 is negative 6. Negative 6 plus negative 9, negative 15. And then negative 2 times 2 is negative 4, plus negative 5 is negative 9. Okay, so I made this a 0. My next step will be to make this one a 0. So row 1 stays the same, row 2 stays the same, and I'm going to change row 3. So let's copy row 1, 1, 0, 3, 2, and let's copy row 2. And now I need to make this a 0. So I'm still working in the first column, so that tells me that I need a multiple of row 1 such that when I add it to row 3, it becomes 0 in here. So notice that I need to multiply row 3 by 3, because 3 plus negative 3 is 0. So 3 times row 1 plus row 3 is my new row 3. So 3 times 0, I can do it in here. 3 times 1 is 3 plus row 3, negative 3, so that's a 0. 3 times 0 is 3 plus row 3, which is 1. I'm sorry. So 3 times row 1. So 3 times 0 is 0 plus 1 plus row 3. So that's a 1. And then 3 times 3 is a 9 plus a negative 4. That's a 5. And then 3 times 2 is 6 plus a negative 3 is a 3. So there you go. I took care of this is a 1, this is a 0, this is a 0. Next, what is my leading entry in row 2? Notice that the first non-zero is negative 3, but this one is a 1. So I can make this a 1 by swapping row 2 and row 3. So row 1 is 1, 0, 3, 2. And then instead of row 2, I'm going to write row 3. I can do that. And then row 2 is row 3 now. Okay, so now I have that the leading entry in row 2 is a 1. So the only thing I have to do is make this a 0. Okay, so making this a 0, that means that my row 1 stays the same, row 2 stays the same. So 1, 0, 3, 2, 0, 1, 5, 3. And then how do I make this a 0? I'm working in column 2, so that means I need to add a multiple of row 2. So notice that if I multiply row 2 by 3, then 3 and negative 3 is going to cancel. So this is going to be 3 row 2 plus row 3 goes into row 3. So 3 row 2. So 3 times 0 is 0 plus row 3, which is 0. 3 times row 2. So 3 times 1 minus 3, that's a 0. 3 times 5 is 15 plus 15, that's a 0. 3 times 3 is a 9 minus a 9, that's a 0. So this is the row echelon form. This is 1 with zeros below it. This is 1 and it's to the right of it with zeros below it. And then there is no non-zero entry in the last row. So we are in the case where we have infinitely many solutions. Okay? So what does that mean? It means that z is not a leading variable. So that means that z can be anything, guys. So this is the row corresponding to x, and this is the row corresponding to y, but the row corresponding to z, it has no z in there. So z is not a leading variable. And what we say is that z can be anything. So we let z be t, where t is a real number. So if c is a t, then what's going to be y? So we do work with back substitution. So from the second equation, I get that y plus 5z equals 3, right? 0x plus 1y plus 5z equals 3. But z is t, so y plus 5t equals 3. So y equals 3 minus 5t. And then from the first equation, I have that x plus 0y plus 3z, but z is t, equals 2. So then x equals 2 minus 3t. So this is the solution. This is infinitely many solution because t can be anything. So the solution is x, but x is a variable of t, so it'll be 2 minus 3t. Y, which is 3 minus 5t, and then z, which is t. There's infinitely many because t can be anything. So if I let t be 0, then the solution will be 2, 3, and 0. If I let t be 1, then it will be 2 minus 3, 3 minus 5, and a 1. So the system is consistent and dependent. It depends on the variable t. Alright, so I want you guys to try to work this on your own, and then I'll write the solution, and then you can see the answer. Alright, so let's do this one together, and if you did it by yourself and you're going to get the same answer, great. If not, let's see where things might have gone wrong. Alright, so we need to find the reduced echelon form and then use back substitution and then back substitution to solve. Okay, so I need this to be a 1 first. I need the leading entry to be a 1. So notice that the leading entry in row 3 is a 1, so I can swap row 3 and row 1. Okay, so that's the first step. So instead of row 1, I'm going to put row 3. And instead of row 3, I'm going to put row 1. And then row 2 stays the same. Negative 2, 1, negative 3, 9. Okay, so my leading entry is a 1. That's good. Now I need to make zeros below it. So I need to make 0 here and 0 here. So let's deal with this first one first. So I need to keep the first row and the third row. And then I'm going to change row 2. So the first row stays the same. The third row stays the same. And then how can I make this a 0? It's a negative 2 now. So what multiple of row 1 can I add to row 2 to make this a 0? Well, 2, because 2 minus 2 is a 0. So 2 times row 1 plus row 2. So 2 times row 1 plus row 2 is going to become my new row 2. So 2 times 1 is 2 minus 2, that's a 0. 2 times negative 1 is minus 2 plus a 1, that's a minus 1. 2 times 2 is 4 plus negative 3, that's a 1. 2 times negative 8, that's negative 16 plus 9, that's negative 16 plus 9, that is, oh my gosh, 7. Okay, I had a brain. Okay, so now we made this a 0. So our next task is to make this a 0. So we're going to change row 3 now. So row 1 stays the same, row 2 stays the same, and then we're going to change row 3. So row 1 is 1, negative 1, 2, negative 8, 0, negative 1, 1, and 7. Row 4. So I need to take a multiple of row 1 and add it to row 4. So notice that I need to multiply row 1 by -4 so that when I add it, -4 plus 4 makes this a 0. So -4 times row 1 plus row 3 goes into row 3. So -4 times 1 is -4 plus 4, 0. -4 times -1, that's +4, plus -3, that's a +1. -4 times 2, that's a -8, plus a 1, -8 plus 1, -7, and then -8, -4 times -8 is +32 plus -31, it's a 1. Alright, so then this is a 0, this is a 0, so we're moving on to the next leading entry. So the first non-zero entry in row 2 is a -1. Well, I can just multiply row 2 by -1, or I can swap row 2 and row 3. Whatever one you want to do. So let's, row 1 stays the same, 1, -1, 2, -8. Let me just swap these two. So 0, 1, -7, and 1. And then 0, -1, 1, and 7. So then my leading entry is a 1. So all I have is I need this to be a 0. Okay, so how can I make this a 0? So we just swapped in here these two. How can I make this a 0? I'm in column 2, so what multiple of row 2 do I need to add to row 3? Well, I can just 1 and -1 that already make a 0. So row 1 stays the same. Row 2 stays the same. And then row 3, I'm going to do row 2 plus row 1. Row 3, I'm sorry, goes into row 3. So 0 plus 0 is 0. 1 minus -1 is a 0. -7 plus 1 is -6. And then 1 plus 7 is a 8. All right, so leading entry, 0 is below it. Leading entry, 0 below it. I need this to be a leading entry, so I need it to be a 1. So row 1 stays the same, row 2 stays the same, and then row 3, I need to divide by -6. So row 3 divided by -6 becomes my new row 3. So -6 divided by -6 is +1, and then 8 divided by -6 is -4/3. Okay, so then this is the row it's not the reduced, it's row echelon form. So that gives me that z equals -4/3. And then from this one, I can get y. So I'm going to get that y minus 7z equals 1. So x minus, oh, I'm sorry, y, I said y. X minus 7 times -4/3 equals 1. So then this gives me that y equals 1. This is 1 minus 28/3, and gives me that y equals -25/3. And then from the first one, I'm going to get that x minus y plus 2z equals -8. So then x minus y, but y is 25/3, so x plus 25/3 plus 2z, so 2 times z is -4/3 equals -8.